All right, so to find a missing angle, right, we're going to use an inverse trig function. What does an inverse trig function look like? Well, this is an inverse trig function. So now, suppose I have an equation that says, okay, sine of theta is equal to 0.2. Okay, so what does that tell me? That tells me that there was this mysterious angle theta. I found the sine of it and I got 0.2. So how would I know what that mysterious angle is? Well, to solve for theta, what I do is I take the inverse sine of 0.2. Okay, so inverse sine gives me the angle to which I know the sine, cosine, tangent. So let's do a couple of examples here. Look at part A. It's telling us that there is this mystery angle x. Somebody found the sine of that mystery angle and they found it to be 1/2. So now I want to know how big was the angle. Now soon you'll be able to do this particular one without a calculator. We're going to use the inverse trig function for this one. So what I do is I say x is equal to inverse sine of 1/2. Okay, now let's go on our calculator. To do inverse sine, it's going to be second sine. That gives you sine with a -1. That's called inverse sine. And I say 1/2. You can either do 1/2, or if it's a fraction that converts to a decimal, a nice clean decimal, I could have also done 0.5. All right, so enter, and I have 30. So that mystery angle is 30 degrees. Okay? So next, let's do the tangent. I have a mystery angle, and tangent of this angle is 12.5. So theta is going to be what of 12/5? Inverse tangent of 12/5. So this is second tangent 12/5. And I get 67.38 blah, blah, blah. Now, it says here in my instructions to round each answer to the nearest angle. So what would that round to? 67 degrees, right? Okay, now, the next one, you're on your own. I'm going to pause the recording for 2 seconds. You're on your own. Go ahead and do that one and we'll get right back. 54 degrees, right, exactly. Okay, so that's how we do that one. So even though we can do that first one, A, with using the special triangles without a calculator, the other ones require a calculator, absolutely. All right, so using that we just learned, let's find the measure of theta here. Now remember, you're looking for an angle, so we're going to have to use inverse trig functions. It says round to the nearest degree. The process is the same. Just like I did in the beginning, you identify the given angle, you label the sides, and you write a trig equation. So we're going to do the same thing. Identify the angle, label the sides. This is going to be opposite and hypotenuse. And now I'm going to write a trig equation. So with opposite and hypotenuse, my equation will be sine. So sine of what? Theta, because that's the angle, is equal to the opposite over the hypotenuse. Now I know at this point everybody has like this urge to simplify the 14/16 to 7/8. Guess what? Because this is still an intermediate step, you don't have to waste your time doing that, because my final goal is to find theta. But I love that everybody is like so eager to do that. I need to find theta. So what would theta be here? Right, inverse sine of 14/16. Okay, and when you go to plug that into your calculator, you can do inverse sine 14/16 You can do inverse sine of 7 over 8. It's up to you. We get 61 and round it to the nearest degree. That's 61 degrees. Okay? All right. The next one, if this is my angle theta, how do I label those sides? What's the 5? Adjacent. And the 12? Hypotenuse. And that would be which function? Cosine. Cosine of what? Theta is equal to 5 over 12. So theta is the inverse cosine of 5 over 12. And how much is the inverse cosine of 5 over 12 these days? 65. All right, I'm taking your word for it. Okay? All right. Now, let's apply some of this. Just by a show of hands, how many have seen this term before? Angle of elevation, angle of depression. Okay, so basically, if I'm standing here and I see a plane approaching, this the horizontal line, at my eyes, that's eye level. That horizontal line is important, and then that angle at which I see the plane, that angle with the horizontal is the angle of elevation. And if I'm the pilot and I'm looking down at the runway or at some people, again, I have a horizontal line of sight. The angle down from that horizontal line of sight is the angle of depression. So this is angle of depression, that's how it looks, and angle of elevation. What do you think? How do you think the sizes of those two angles compare? Why would they be equal? Okay, so if you remember back in geometry, if you have two parallel lines and another line going through them, when you create alternate interior angles, they are congruent. So angles of elevation and depression are congruent. When you least expect it, man, that stuff comes back to haunt you. Okay? All right, so you're hiking. And the mountain you're going to hike, it has an elevation of 1,500 feet. When the hikers look down at an angle of depression of 36 degrees, now mind you, nobody is like really depressed here, right? They're all happy, they're hiking, okay? But when they look down, they have an angle of 36 degrees and they could see the campsite down below. What we need to find now is the horizontal distance between the foot of the mountain and the campsite. Okay, so that distance. All right, so that's fine, mountains and tents and fine. Those are all pretty, but when it comes to the math, all I need is a triangle. Okay, so I look for a right triangle. And oh, look, there's a right triangle right there. Now, if that's the right triangle, how big is that vertical distance? How much? 1,500 feet, right? It's not the units are important. It's not an ant farm, so it's not centimeters, right? It's a mountain, it's in feet. And that horizontal distance, we're calling it x. Now I need an angle. 36 degrees. Okay, so this angle is 36, right? Okay, so here's a question for you. That's totally awesome what you're doing. Before we go there, here's a question for you. In this triangle, where would there be a 36-degree angle? The one on top or the one on the bottom? The one on the bottom is 36 degrees because it's alternate interior angles. Now, what you could have also done is what Mason is doing. That this is 90 degrees up here. Okay, so we know now that this is 36 degrees. What you could also do is say this is 90 degrees. So this little bit here is 90 minus 36. That is totally fine as well. Okay, if you do that, you would be using a different tangent. All right, so if we label it the way we have here, how do I label the sides? The 1,500 would be the opposite to the 36, and the x would be the adjacent to the 36. And I'm going to use tangent, thank you. Tangent of what? Of 36. I find that's the most common mistake students make is they don't put the angle there. But, you know, so I always try to train everybody that it's tangent of an angle, all right? So it's 1500 over x. And now it's x tangent 36 equals 1500. So x is 1500 divided by tangent of 36. So that will be tangent of 36, 2064.57, etc. And what does it say to round to? Nearest foot, so that will be, yes. So when we round, we use those squiggly equal signs. That means approximately 2065. That tells me that I've rounded it. Now, is this a complete answer?
No, you're right.
Feet. Thank you very much. I am, believe it or not, I mean, it makes a huge difference. And for me especially, it makes, I think, even a bigger. How many sides to a triangle?
3.
How many angles to a triangle? That's 6 total, right? 6 total elements. So when it says solve a triangle, what does that mean? You just have to find everything. In order to solve a triangle, you have to have 3 of the 6 given, and then you have to find the other 3. And we can use trig functions and inverse relations to solve a triangle. All right, so here we're going to solve this triangle. And it says round side lengths to the nearest tenth, angle measures to the nearest degree. So let's do that. What I like to do first is make a little list of stuff I need to find. So what am I missing here? Oh, by the way, a little bit of, I'm sure you know this already, but I'm just going to repeat it. We label angles using capital letters, A, B, C. Sides are labeled using lowercase letters. And the way we do it is, in order to be consistent and make it easy, capital C faces a side of lowercase c, capital B faces a side of lowercase b, and so on. That's just the most efficient way that we have found to label things. All right, so I'm missing angle A here. What else? Angle C. What else? Side C. Okay, now, what do you guys want to find first? Okay, let's go. Let's go alphabetically. Let's find angle A first. Okay, so identify the angle, label the sides. It doesn't make sense to label side C because that's an unknown. What's the 37? Hypotenuse and opposite. So that will give us sine, cosine, tangent. Sine of A equals 37 over 20. No, it's not. That will be a number greater than 1. So it's got to be 20 over 37. So A is inverse sine 20 over 37. And that will be how much? It is 32.7, but I was told to round to the nearest degree, so that's about 33 degrees. So for A, I'm going to write 33 degrees. Now, what about C? What about C? Is there a quick way to find C?
Yeah.
What's the quick way to find C? Awesome. All of these must add up to 180. Okay? You can go a step further and say these two acute angles have to add up to 90. It's up to you. So, C is 180 minus 33 minus 90. How much did we say it was? 57 degrees.
Is that approximate or do you like?
Well, we rounded this to 33, so that'll be 57. We want them all in degrees. Round it to the nearest degree. Now, how about side C? All right, so for side C, let me erase some of this here. I'm going to use that angle 33 degrees again. So this is the adjacent, and you can use either the hypotenuse or the opposite. What else could you do? Pythagorean theorem. So it's totally up to you. What do you guys want to do? Pythagorean theorem. Let's do that. So c squared plus 20 squared is equal to 37 squared. C squared plus 400 is equal to 37 squared, which is how much? Okay, and if I subtract, right, and when I take a square root, (31.1 degrees, 31.1. Okay. All right. Should we do one more, or are we okay with this? One more? Let's do one more. Okay. So, what we're looking for here is capital T, little r, little s. Can we find capital T very quickly? Yeah, because it's 180 minus 90 minus 23. So it's how much? 67 degrees. Now, I like to use the angles that I was given by the problem, because what if I made a mistake with my own? Here is an angle. R is the opposite. This is the adjacent. That looks like what? TOA, tangent. Tangent of 23 is equal to R over 35. So R is 35, tangent of 23. And what do we think? How much do we think that is? (35) tangent of 23. How much? 14.85, so we can say 14.9. Let's use trig functions for s as well. So what I have to do, in order to switch to a different size, I have to erase all of my labels and relabel. So s will be hypotenuse, and 35 is the adjacent. That's cosine. Okay. So s times cosine 23 is 35. S is 35 over cosine 23. Cosine 23. How much is that? 38.0, right? A little bit of like checking. So we know that the hypotenuse is the largest side. And then, make sure I got 38. Is that the largest of all the numbers? Yeah, so I must be on the right track. Okay. All right, let's do this last one. You're given one trig function, and you have to find the values of the rest. So How many total trig functions are there? 6. If you're given 1, you have 5 left over. All right. So what we do here is, I'm given this. I need to draw a triangle. All right. We draw a right triangle. We label an angle for theta. I like to make it the bottom one, just because it's more consistent with everything we're going to do. And then I want to label the given trig function. So cosine of theta is 2 over 5, right? Okay, cosine is what over what? But it's adjacent over hypotenuse. So that means the top number is the adjacent side, and the bottom number is the hypotenuse. So the top number 2 is the adjacent side. The bottom number is the hypotenuse. Now, I need to find the missing side. I use the Pythagorean theorem for that. So here's the missing side x. Okay? Let's find that missing side. 2 squared plus x squared is equal to 5 squared. 4 plus x squared is equal to 25. X squared is 21. X is root 21. Okay. Now, last but not least, find the trig functions. All right, so let's go here. Sine of theta, now I just have to do, opposite over hypotenuse, da-da-da-da-da. So what would sine of theta be? What over what? Root 21 over 5. What? Cosine of theta, I already know, so I don't have to write it. Tangent of theta would be what over what? Root 21 over 2. Now, I need to find cosecant of theta, secant of theta, cotangent of theta. Cosecant of theta, I just take the sign and flip it. So, 5 over root 21. But can I leave it like that? No, I need to multiply. This is 5 root 21 over 21. Now, if you can go from 5 over root 21 to the final answer without writing what I wrote in blue, that's fine. If you need to write it, totally fine. Okay? For secant of theta, what am I going to flip? What am I going to take the reciprocal of? Of this one, so I make it 5 over 2. And here, 2 over root 21. How much will that be if we just go to the final answer? 2 root 21 over 21. If you need to write down that you multiply top and bottom by root 21, that's totally fine. Now, that's pretty much it for the lesson. When you're doing the homework, these are the problems that you're going to be doing for homework. So for instance, if you look at number 9, and remember, you can look at the PDF on Haiku for these. If you look at number 9, it's actually identical to this last problem we solved. So what you're going to do is look at one of the homework problems. Go back to the notes and try to find an identical one, or the one that is most similar, and mimic. So for number 9, let's say, you say, oh yeah, that's just like this one, okay? And you say, oh my gosh, okay, so what am I going to do? Oh yeah, I'm going to draw a triangle. Then I have to label my theta. Then I have to label what I'm given. Then I have to find the missing side. I bet you they will all follow the same steps, okay? So that will be due next class.